So, about those R-value references in our project. I've been thinking that we might need to be more aggressive with them. When you have a large code base like ours, every little bit of optimization helps.
Yeah, but aren't they just temporary objects?
Exactly. And that's why they're so useful for move semantics. You can take an object that's about to go out of scope and transfer its resources instead of copying them. It's like passing around a basket full of apples without actually moving the basket itself.
But doesn't that mean the original object becomes empty?
Sure, it does. That's what makes it an R-value reference. It represents something that is no longer needed in its current form. Think of it as giving away your old bike because you've got a shiny new one. The old bike still exists, but now someone else gets to use it.
What happens if there's an error during the move operation, though?
Well, that's where exceptions come into play. If something goes wrong, you'd want to make sure that either both states are valid or neither is affected. It's like trying to swap baskets at a market. Both parties should end up with something worthwhile, even if the exchange fails halfway through.
And how do we ensure that the compiler uses moves over copies automatically?
The key is marking functions with and. That tells the compiler this is an R-value reference, and it can apply move semantics. It's all about context and letting the compiler know what's disposable and what isn't. Like knowing which fruits are ripe enough to pick from the tree versus which ones are still growing.
Got it. So it's really about making smart decisions on when to copy and when to move based on the life cycle of the objects.
Precisely. And remember, using move constructors and assignment operators properly can drastically reduce unnecessary allocations and delecations, especially in tight loops or data-intensive operations. It's like always having fresh produce. You don't want any wastage.
Makes sense. So we should review all our classes and see where we can add these move constructors.
Absolutely. Start small if you must, maybe with some test cases first to get comfortable with it. Then gradually expand throughout the codebase as you gain confidence. It's a big step towards efficiency and performance improvement, much like picking only the best crops from the field, rather than everything at once. Speaking of which, let's talk about optimizing object transfers with STD. Move for performance gains. Have you seen how it can really speed things up?
I have seen some improvements, but I'm not entirely sure how to apply it effectively across our codebase.
It's all about identifying the right places where you can use STD. Move. For example, when you pass an object to a function that will take ownership of it using STD, move can prevent unnecessary copying and make your program faster.
So it's like handing over a fully loaded basket directly instead of filling another one?
Exactly. By using STD, move, you're telling the compiler that you don't need the original object anymore, and it can safely transfer ownership without copying. This is particularly useful in functions returning objects by value, or when dealing with containers like vectors.
That sounds straightforward. But how do we decide where to use it?
Good question. You want to look at areas where there are heavy allocations or frequent copies. For instance, if you have a function that returns a large vector, consider using std move to return it by value. This way, the vector's resources are transferred efficiently rather than being copied.
And what about inside loops? Does it help there too?
Definitely. Inside loops, especially nested ones, every microsecond counts. Using std, move on temporary objects within loops can significantly reduce overhead. It's like making sure each transaction at the market is as quick as possible, so everyone gets served faster.
Makes sense. So we should start profiling our code to find these bottlenecks then?
Yes, exactly. Start profiling critical sections of your code and identify where std, move, could be beneficial. Once you pinpoint those spots, refactor carefully to ensure everything still works correctly and efficiently.
Sounds like a plan. We'll start looking into profiling tools and see where we can optimize.
Great idea. And remember, while SDD, move, can bring significant performance gains, it's important not to overuse it. Use it judiciously where it makes the most impact, like ensuring your baskets are handed off smoothly without any wasted effort. Now, let's talk about move constructors and assignment operators. When do you think it's necessary to implement them manually?
I've read that it's generally a good idea if the class manages its own resources, but I'm not sure when it becomes absolutely essential.
That's a good point. If your class owns resources like dynamically allocated memory or file handles, implementing move constructors and assignment operators can be crucial. They allow for efficient transfer of those resources instead of copying them, which can save a lot of time and memory.
So it's more about managing resources efficiently, right?
Exactly. Take, for example, a class that holds a large buffer of data. Without a move constructor, every time you create a new instance from an existing one, you'd have to allocate new memory and copy all the data over. With a move constructor, you just transfer the pointer to the buffer and set the original pointer to null. It's much faster and cleaner.
That makes sense. But how do we know if our class needs them?
A good rule of thumb is to ask yourself whether your class has any resource management going on. If it allocates memory, opens files, or holds any kind of non-trivial resource, then implementing move operations is likely beneficial. Additionally, if you're finding performance bottlenecks related to object creation and destruction, manual implementation can help.
Okay, so if we have classes that manage their own resources, we should definitely consider adding these.
Yes, definitely. And don't forget about the move assignment operator as well. It complements the move constructor by allowing an object to take ownership of another object's resources when assigned. This ensures that even in cases where objects are reassigned, you're not duplicating expensive operations.
Got it. So we should review our classes that manage resources and see if adding these would make a difference.
Absolutely. Start with the ones that seem to have the most impact on performance and work your way through them methodically. It's like ensuring each basket in your inventory is handled with care, so nothing gets wasted or duplicated unnecessarily.